Hello everyone and welcome to our tutorial on object-oriented programming. Before we launch into the specifics of our project, it's important to get a little bit of background information about this main topic of object-oriented programming. So what is OOP, short for object-oriented programming? This is simply a style of programming that makes use of objects, which are data structures in our code. So we use these objects to represent real-world entities. Real-world entities often have state and behavior, and that's what we're trying to model in our objects. We use these objects to store and manipulate data within a program, as well as to execute functions. By this point, you should be familiar with the concept of using variables to store program data and using functions to run functionality and to manipulate that data in some way. Well, objects do exactly the same thing. The difference is that we store these variables and these functions inside of objects. So typically, our objects will use these variables to represent their state. We can kind of think about these as being attributes or properties of an object. For example, let's say we created a robot object that you see pictured here. Well, some of the properties that a robot might have would be name, age, and perhaps whether or not they're a zombie. Let's say we're building a video game with zombies in it. Well, these can all be represented with variables. The only difference is that we store the variables inside of the object rather than just letting them run free. The exact same thing goes for functions. So what is a class then? Well, a class is simply the blueprint of an object. Within a class, we essentially specify the blueprint, and with an object, we build what's on that blueprint. We call this creating an instance when we use the class to create an object. The class is really there just to outline the properties and what an object can do through its functions. So, referring to this picture on the right, if we think about the recipe as being the class, then the actual cupcakes shown here are the objects. These are kind of the recipe come to life. These are what we would call instances of the cupcake. The idea of a recipe being a class and the actual finished baked good being the object is a good analogy to use moving forward. So keep that in mind when talking about classes and objects. So this is a really quick intro into what classes and objects are. Obviously there's a little bit to them more than what we've just listed here, but we'll cover the specifics as well as refresh some of these techniques as we go through these tutorials. Okay, so I recommend that you kind of go back and review this tutorial so that you get a better idea of what classes and objects are, and when you're ready to move on, we'll start the 4 stages of project management. So, thanks for watching, and we'll see you in the next tutorial. Hey everyone, and welcome to part 2 of our project implementation series. Now that we know how to handle text input and output, let's start writing some actual project code. So we'll start really simple here by implementing our game object class. So our goal here is to create our very first own custom class. In this case, it's going to be the game object class, and we're going to use this throughout the rest of our project. So a game object class is going to need some fields and an initializer, and it's also going to need some methods as well. I think we'll divide this into 2 parts. First, in this part, we'll do the fields and the initializer, and then in the second part, we'll do the methods. That way, we're not throwing too much at you all at once. And if you've forgotten what all 3 of those words mean, don't worry about it. We'll review fields, initializers, and methods as we go. Okay, so before we start writing any actual code, it's good to get an idea of what we're going to be writing, and we can do so using a UML diagram. So a UML diagram stands for a Unified Modeling Language Diagram, and is used to plan out our classes and objects that we're going to use in our code. So they generally follow this format. First, in the top bar, we have the object or the class name. In our case, this is a game object. In the box underneath it, we specify which properties or attributes this game object is going to have, and typically we add in the type as well. So think about these as variables that represent properties that this game object will have. Well, every game object in our game is going to need a name, an appearance, a feel, and some sort of a smell associated with it. All of these variables in our case will be strings. Okay, so again, think about these as being properties of the game object. We're going to implement them as variables, but when a variable belongs to a class, it is called a field. So anytime you hear the word field, just think variable. Okay, so I know I threw a lot at you at once. Hopefully this will become a lot clearer once we start writing any code, which is exactly what we're going to do. So let's head over to our code now. Okay, so I figure it's probably best to start with a clean slate. You can keep the code that we wrote for the input-output tutorial if you'd like, but we're going to be using input-output functions a lot anyway, so I figure we may as well clear them out. Okay, so we'll get started with our game object class. The first thing that we want to do is use the class keyword to create a new class. Okay, in our case, let's call this a game object like so, and in true Python fashion, we're going to use a colon to denote that any code that comes after this belongs to the game object class. Okay, so right off the bat, you'll notice that the naming syntax is a little different. We're using camel case. So typically in Python, for functions and variables, we'll separate the words with underscores, whereas with class names, we use camel case like so. You don't have to, but this is common practice. Okay, so what again are going to be our four fields, our four properties? We're going to need a name. Okay, whoops, not name error. We just want a name like so. We want an appearance. We want a feel. And we want a smell associated with the game object. Now we know these are all going to be strings, so what we'll do for now is just add in empty strings so that these have some sort of value and we get rid of the errors. Okay, so in Python, we don't actually have to do this to create our fields. We can do it all in one step using the initializer, but for now, just as a reference, and because this may be the first time you've ever created a class, we'll do things this way so that you can see these very clearly. So as of right now, these four items are fields. They're just variables that belong to our game object class. Okay, they act just like any other variable would. You can see that they've got a name, they have been assigned a value, they just happen to be within the context of our game object class. Okay, so think of these as being properties that every game object will have. Okay, so as I mentioned, we're also going to be using an initializer to set up these variable values. I know we've set some value here, but realistically, we want to be able to set these values every time we create a game object. So to do that, we can use a special function called an initializer that looks like this. We'll do the two underscores, okay, like so. And we'll also need the self keyword. Okay, so to start off with, this is a function, so we need the def keyword to make it a function. We're going to give it a name, in this case init. We're going to open up the parentheses, and we're going to use the colon to denote the body, so any of the function body goes underneath here. So in our parentheses, we'll put any parameters that we want to take in, just like we would any other function. However, there's a couple things here that are different. First of all, these two underscores and the name init are very specific to an initializer. Every initializer we create has to have this syntax. Okay, and that's because it's a very special function that is used to create a new instance of our class. Okay, so we're going to use the code in this initializer body to set up any new game objects, which in our case is going to be setting values for these four variables here. So in order to do that, we're going to need to take in some parameters here. Okay, so besides self, we'll need a parameter for the name, one for the appearance, one for the feel, and one for the smell. Okay, let's just give ourselves a bit more room. So just like any other method, any other function rather, it's going to need parameters, and we'll use those parameters in the body. Okay, so let's talk briefly about the self item here. For every function that you add to our game object class, or any other class for that matter, you will need this self keyword. There are some exceptions, but we won't get into them here. Essentially, we use the self keyword to denote that this function belongs to this specific class, and we can access any of the class's properties or functions using this self keyword. And that's exactly what we're going to do to set up our 4 variables like so. We're going to say self.name is equal to name. I'll do the same with the other 3. So self.appearance is equal to appearance, self.feel is equal to feel, and self.smell is equal to our smell. Okay, so this might look more complicated than it actually is. Essentially, all we're doing is we're taking in these 4 values here. We can ignore self. We don't need to pass anything in for that. But we're taking in 4 values, and we're just setting the name, appearance, feel, and smell of our GameObject class using those 4 values like so. We're just using the self keyword to say that each of these name, appearance, feel, and smell belong to this class or will later belong to the instance of this class. So that way we know when we say self.name, we're fetching this variable here and not just using the parameter here. Okay, other than that, we can kind of treat our initializer as just another function. We can put any kind of logic or control flow, anything else that we want in this function body. Just know that this is a special function that is used to set up the initial values of these variables. Now, Python is pretty unique in that we don't even have to do this. We can actually use our initializer to create these fields and set their values. In fact, if I remove this, you'll see that I get no errors. Okay? A lot of other languages don't let you do this. They need this sort of a format. Python is not that way. Okay, so you don't have to do this. You can just set them up in the initializer, but we'll leave them there for now just as a reference. It's up to you whether you want to keep them or get rid of them later on. Alright, so I think this is probably a good place to stop. In the next section, we'll focus on the methods. Again, just kind of review what we've covered here. These are our 4 fields, which are just variables that belong to our game object. Okay, we set some values here. Again, they represent properties that a game object will have. Okay, we created this initializer function, which is a special function that will take in our case, a value for each of these variables, and it will set them appropriately down below. By the way, we don't have to take in a value. Just like any other method, we could add a default value if we wanted, like so, but in our case, we do want to set them through these parameters. As I said, when we come back, we're going to be focusing on methods, which are essentially just functions within our class. So stay tuned for that. Thanks for watching, and see you in the next one. Hello everyone, and welcome to part 2 of our game object implementation tutorial. In part 1, we created our game object class and we added some fields and an initializer. Now we're going to finalize our implementation by adding some methods to that same game object class. This will allow us to add some functionality to this class so that each game object can do more than just contain properties. So from the previous section, we had these 4 fields, name, appearance, feel, and smell, and we used our initializer to set them up. We're going to need 3 more methods, which are going to be look, touch, and sniff, and these will be just ways to print out our appearance, feel, and our smell properties. So when creating a UML diagram, the very top is the class name, the middle box is the fields or the properties, and the bottom box is the methods or the functionality that this class will have. Now, just as a refresher, the method word just means a function that belongs to a class. So similar to how a field is just a variable belonging to a class, a method is just a function belonging to a class. So if you hear method, just think function. Okay, so enough said, let's head over to the code. We'll implement these 3 methods, look, touch, and sniff, and then we'll be able to wrap up our game object implementation. Okay, cool. So we know that we've created our initializer, so that's one of the 4 methods already done, and it's just a way to set these 4 values or these 4 fields. Now we're going to create 3 more. The first is going to be look, and I'll add in the self keyword. Don't worry, I'll come back to that in just a minute here. I'll add the touch method, and also we want the sniff method. Okay, so these are our 3 methods that we want to implement. Because these are methods that belong to a game object, we need to add in the self keyword. Again, that will give us access to any of the properties, name, appearance, feel, or smell, as well as any of the other methods that we might need. Okay, so because we're going to be using these three methods just to access our appearance, feel, and smell and print them out, we can basically use a very similar implementation for each of them. Rather than having the actual print call within these methods, what I'm going to do is I'm just going to use these to return a string. So hopefully you are familiar with functions. They can take parameters as input and they can produce output through the use of return statements. So we're just going to return some sort of a string here, here, and here as well. Now we want these to contain some sort of text. Again, thinking about the game context, we're going to use these to print out some sort of an action and then of course either the appearance, feel, or smell. So we want it to say something like you look at the and then the name, okay, and then it's just going to print out whatever appearance that we have, okay, and then we're also going to add a new line character just to make sure that when we do go to get this and print it, it goes onto a new line. Okay, so if we were to run this, this is just going to return name and appearance. We want the actual name and appearance that belong to our game object. So in order for to fetch those, we're going to need self.name and self.appearance. Now again, this isn't quite doing what we want. This is just going to print out this string exactly as it is. So what we're going to do is use a bit of formatting. We're going to put an F here to denote that this is a formatted string, and we're going to wrap these in curly brackets like so. Okay? Now you may or may not have seen this before. Essentially, when we put the F before, this just gives us a way to pass in variables. In our case, this is just going to be, this should be appearance like so. This is just going to be a call to our name. So self.name means whatever name is assigned to our game object here. And self.appearance is whatever appearance that we've set in our initializer. And this way we can put in variables and stick them right within strings. Okay, so it's nothing too crazy. It's just a way to add in some formatting. Okay, so what we're going to do is essentially do the same for touch and for sniff, but this is going to be something like you touch the, and we can keep name, but of course instead of appearance we want the feel, and we'll do the exact same for sniff. This is going to be something like you sniff the name, and then we want to print out whatever our smell is. Okay, very good. Now, these three methods are implemented, but before we go any further, let's take a step back and review exactly what we did. So we've created these three methods, which again are just like functions that belong to our game object class, or to whichever class they're in. We don't need any parameters, so we don't need to pass anything special into these methods, but we do need the self keyword for each of these methods, because that will give us access to the properties that we need. So we're going to need to access the name and appearance. Note, if we get rid of self, this is going to give us an error because it doesn't know what name is. As soon as we add self.name, it says, oh, okay, you're talking about this name that belongs to this current class. Also, we are making use of formatted strings. Again, this is just a way to pass in variables like so, okay, through these curly brackets, and we do so simply by putting the F at the beginning of the string. So you can put whatever you want in here. In fact, you can put a whole equation. It will calculate the equation and it will store the results here. And at the end, you'll get one big string. Okay, so I think it's time that we see this game object in action. We've put in a lot of work to create this class. Now let's create a game object so that we can make use of this class. Okay, so we're going to start this just like we would any other variable. I'm going to create a variable called game object. It is going to be an instance of our game object class. And we're going to use our initializer to set the name, appearance, feel, and smell. So let's just do something like a knife. I'm not going to jump into setting a proper appearance, feel, or smell. I'm just going to say some appearance because this is really just a mock variable. Some feel, and then some smell. Okay, like so. Okay, so what is going on here? Well, we're creating a new object. In our case, this is a new game object, so it's going to be game object like so. And instead of doing anything crazy with .init or anything like that, we can use the initializer's special syntax to open our brackets like so, and then we just need to pass in a value for each of these 4 parameters, just like any other method or function. So at this point in time, this game object variable is of type game object, and it has knife set for name, has some appearance set for appearance, some smell set for some feel set for feel, and some smell set for smell. We can access the properties of our game object using .syntax like so. For example, let's say we wanted the name, we could do gameObject.name. Okay, we can print this out if we'd like. We'll go ahead and run it, and we should see our knife being printed out. We can even modify it. So game object.name is equal to, and then something else, maybe it's a spoon. Okay, you can see that we have now modified the name because we set the name property of game object by doing game object.name equal to this new value, which in this case is spoon. Okay, so you can access and modify properties or fields through the use of this syntax. You can do the exact same thing with methods. So let's say we want to just comment that out because, in fact, I'm just going to delete it altogether. Let's say we wanted to get this sniff, okay, and print it out. So what we could do is print game object.sniff, okay, and because it's a method, we use the syntax to access the method, in this case sniff, gameObject.sniff. We go ahead and print that out. That should return a string, and indeed it does. You sniff the spoon and then some smell because, again, the name is spoon and the smell is equal to some smell. And that is really all there is to it. So we now have a complete implementation of our game object class. We has a name, appearance, feel, and smell, has an initializer to set things up. It has these 3 methods, look, touch, and sniff, to retrieve some properties of it. We know how to access and modify properties using the syntax, as well as call methods to execute the code within, again using the syntax. Anytime we create a new instance, it is an object, and this class is just the implementation of how this object should act. Okay, so definitely take some time to review what we created here. Make sure you get your definitions straight. Play around with this game object, and when you're ready to move on, we'll start implementing our next object. So that's it for now. Thanks for watching, and see you in the next one.